Hi everyone, welcome to your lesson on the Big Bang Theory. Before we get into the Big Bang Theory, we need to talk about the difference between a theory and a law. So, just basic in general, a scientific law describes something that has been observed by scientists, but it does not explain how or why that something works. So the explanation for how or why something works is called a scientific theory. So an example that I like to give is the law of gravity. So the scientific law describes something that has been observed. So if you take an object and you drop it straight down, it's always going to fall down. That's the scientific law of gravity. The law itself does not explain how or why gravity works. That's the actual theory of relativity. So the theory of relativity is the explanation for how the law of gravity works. So laws are the starting place, and theories essentially are the descriptions of the laws. So this lesson is focused on the Big Bang Theory. So the Big Bang Theory is an effort to explain what happened at the very beginning of our universe. According to the Big Bang Theory, the universe began 13.7 billion years ago. And remember, this is a theory. This is a widely accepted theory in scientific community. This is not a theory that everybody has to believe. This is one theory for how the universe started. So I'm going to abbreviate the Big Bang Theory with BBT on the slides. So you'll see that BBT states that the universe began from a singularity. I'll show you a diagram of a singularity in just a minute. Began from a singularity, a single point that was very hot and is now expanding and cooling still this many years later. A singularity, the actual definition for a singularity, is a zone of infinite density. So basically everything in the whole entire universe was packed into this tiny, 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 tiny little speck, not even observable, and it was infinite density, which means super, super, super heavy. Atoms could not form at first because of the extreme heat. So we did not have atoms with the initial, quote, Big Bang. So here's a diagram of a singularity. It's not actually a dot like you see on the screen, but that's the best way for scientists to give a visual example of it. So every single planet, star, everything in the whole universe, according to this theory, is said to come from this singular point of infinite density. So some evidence for the Big Bang Theory. So again, theories describe laws. The theories are not accepted if there's not enough evidence and if the evidence doesn't prove to be true. So cosmic background radiation is the first piece of evidence for the Big Bang Theory. And cosmic background radiation is something that moves in front of our universe. So right now our universe is still expanding. So when the Big Bang happened, what happened is everything came out, the universe came out of that singularity and is moving away, all edges of the universe moving away from one another. So the universe is expanding, but in front of it is this radiation. And when you view the night sky with a radio telescope, through the radio telescope, you don't see black, but there's a faint glow. That faint glow is called the cosmic background radiation. And this slide right here, you can see color differences. And the color differences in this slide are variations in temperature. And so that's of cosmic background radiation. When you see temperature differences, you can see that that part of what you're viewing, some parts are hotter, some parts are colder, which tells you they're away. Okay, nebulae. A nebula is a huge cloud of dust and gas. The plural form of nebula is nebulae. There's nebula, the pictures from telescopes are absolutely gorgeous. Here you see the Orion Nebula, the Eskimo Nebula, and the Crab Nebula. Crab's my favorite. It's so beautiful. There's all sorts of blues and oranges and yellows, and those different colors come from different gases, and they come from different gases that are different temperatures. So, galaxies now are the fuzzy patches of light that are scattered among the stars. If you look up on a very clear night and you are not in the city, or you are in a part of the city that is very dark, there's not a lot of light pollution, you can actually see fuzzy patches and you can see galaxies up in the sky. Variations. So like the shape of the disk can look different based on the different kinds. Our galaxy is the Milky Way, and we are a spiral galaxy. And if you look really closely, you can see this little arrow that's pointing to the sun. That's where the sun is in relation to the whole rest of the Milky Way galaxy. So you can see that there are so many galaxies in the universe, but then just looking at our galaxy and looking where the sun is and looking where all of our planets are, you can see just how big our galaxy that we live in is.